Welcome to homework.
In this question, we need to determine the HFG of refrigerant-134a at 10 degrees Fahrenheit using two methods, the Clapeyron equation and Clapeyron-Clausius equation. Okay. Then, so in part A, the Clapeyron equation. Okay, it is dp dt at saturation is equal to HFG divided by T times VFG. So HFG is equal to T times VFG dp dt at saturation. Since we don't have functions to differentiate, so we'll be estimating using finite quantities. So the temperature times Vg minus Vf at 10 degrees Fahrenheit times delta P divided by delta T at saturation at 10 degrees Fahrenheit. Okay. Okay, so we need to convert Fahrenheit into Rankine. So 10 plus 459.67 R. Okay, so the specific volume at 10 degrees Fahrenheit for Vg and Vf will be 1.7358 minus 0.01200, and this is in the units is feet cube per lbm. Okay, and then the delta P over delta T will be using the P saturation at 15 degrees Fahrenheit minus the saturation pressure at 5 degrees Fahrenheit divided by 10 degrees Fahrenheit. Okay, so we have 469.67 Rankine times 1.723 feet cube per lbm. Then we substitute the pressure by reading the table. We have 29.759 minus 23.793, and the unit is PSIA, then divided by 10R. Okay, so if you calculate this, you get 483.0 PSIA feet cube per lbm. Okay, and you convert to BTU, it's going to be 89.38 BTU per lbm. Okay, so note that 1 BTU is equivalent to 5.4039 PSIA feet cube. Okay, and then we compare this with the tabulated value. Okay, so the tabulated HFG at 10 degrees Fahrenheit is equal to 89.25 BTU per lbm. Okay, so this is the calculated answer in part A, and then we found that this is 0.1, it's off by 0.1%. Okay, so now we move on to part B. We'll be using the Clapeyron-Clausius equation. Okay, this equation looks like this. Natural log of the ratio of pressures at saturation is approximately equal to HFG divided by R times 1 over T1 minus 1 over T2. Okay, so we'll be using similar values from above. Okay, so the pressures. Okay, the P2 is 23.793 psia. P1 is 29.759 psia. Okay, this is approximately equal to HFG divided by R, which is 0.01946 BTU per lbm R. Okay, and then we need to convert the temperatures into Rankine. Okay, so we have 15 plus 459.67 R minus 1 over 5 plus 459.67 R. Okay, you calculate this, you have HFG is equal to 96.04 BTU per lbm. Okay, so if you compare with the tabulated value, we found that this is off by 7.6% error. Okay, it's off by 7.6%. Okay, so that's all for this question.